Hey everybody, welcome back. So let's talk about how we can visualize geospatial data. So the basic kind of map that you're probably used to seeing in a variety of places is called a choropleth. A choropleth is some way to encode a variable, one variable, in spatial location. Okay, so we plot a map and we color in parts of the map in ways that show us the level of that variable. So choropleth maps are very useful for visualizing regional patterns, right? As things change from one region to another. Now, there are a few do's and don'ts with this kind of stuff, right? So if you use a weird color scheme, it may not come across without a great deal of thought. So typically we are very used to a hot color scheme where high values are bright or hot colors, right? And low values are dark colors or cool colors. Either one works. Okay? So don't do the opposite. So choropleth maps are really for showing you a single variable. It's hard to compare two maps side by side like we see here. In fact, it would be generally better if you're trying to show relationships between two variables to go back to our old standby, the scatter plot. Okay? Now, what are they good at showing, choropleths? They're good at showing big picture kind of stuff, right? They're good at showing how things are changing in a broad way. They are apparently good at attracting magic. Thanks, dude. But what they're not so good at, these choropleth maps, is showing fine detail differences, right? If you want to make comparisons that require somebody to think for a minute and not just glance, you're probably better off with a different kind of visualization. By the way, in case you're interested, Magic is trying to stick his head most of the way in my water glass so he can drink. Thanks, dude. All right. Another important thing with choropleth maps is that generally you should display relative differences, or as I like to call it, normalized data, right? When I say that, relative numbers or normalized numbers, what it means is that whatever we're measuring, if it's unemployment, right? We don't want to say 100,000 unemployed people. We want to say how many unemployed people per million, okay? Per million people in that region. Why? Because if you look at things that are raw numbers, all you're going to end up with is a heat map of population. Thanks, Kat. Magic agrees. Okay, so, right, like here's an example of that. Where are students attending their charter schools, right? The majority of charter school student population is in Los Angeles, San Diego, or the Bay Area. What else is mostly in those locations? Oh yeah, people. People are mostly in those locations. And this is another example of where if you're not careful with the geospatial analysis, all you end up seeing is a population map. So that's why instead of showing raw numbers of charter students, it would have been better to show, numbers of charter students per million population. Okay. So when we're trying to do some sort of analysis, most of the time, instead of starting at the level of a big geographical region like a state, it would be nice to look at smaller, finely detailed things. So as long as you have enough data where you're not just seeing noise in, like Provo, Utah's dot, right? So if you need to lump everything together so you get to the Utah level, because that's where your data is good enough to get an accurate picture, okay, that's fine. right? But if your data is good and it's well covered and you can get down to the level of Provo, Utah, then you should probably take a look at that, because you're going to miss various things when you're looking at a high level of abstraction. Okay. Another very, this kinds of maps have been very commonly used to look at election stuff. So when we have just had an election, I think we pretty much have to take a quick look at some election maps. So let me bring that up. So this right here, as we are looking at it, is your standard state level map of which person won the vote in that state. Now this is a weird thing, just FYI if you're not already up on the American political system. So we all vote, individuals, but when it comes to electing a president, it's not my direct vote that counts. It's what everybody in my state decides. So if 51% of my state decides Joe Biden, then my entire state's vote goes for Joe Biden. Okay? If I lived in Utah and 51% of my state went for Donald Trump, then that would be the vote for the entire state of Utah. But the reality of how many people voted, even California has a fair number of Republicans, like 40% of the population, something like that. And even Utah has a fair number of Democrats, something like 35% of the population. Let's take a look. Oops, yeah, so that's it. And then I need to go over here. Right. Okay, so let's take a look at this. Here is a map from Engaging Data, which is loading all of our 2020 election stuff. So you can see the map of the individual counties, which is the level of report that we have about who elected what president. So we can show with this kind of map a choropleth showing red or blue, right? But let's see what else we can do. We can visualize with symbols, with markers, with circles, how much land is in each one of these reporting regions, okay? And we can color that reporting region by the blue for Democrat, red for Republican kind of thing, right? And the darker, more saturated that color is, the more strongly that region voted for the candidate. So fully saturated colors are going to be in that 70-80% for the candidate range, and more wishy-washy colors are going to be getting close to that 50-50 mark. Okay. Well, but it's not land that votes, it's people, right? So we can reorganize this same map by population of the region. Okay? Oh, very, very different, right? In the one hand, this map here, the land map, shows a large amount of red. And it shows that large amount of red because rural people in farms and small towns tend to vote Republican. Okay? But when you show population circles, you can see the US's major cities jumping out at you in these giant symbols. And you see that all those little farms in Kansas, you see what their relative size is to the big cities. So many of those red dots shrank way, way down. Okay, as you can see here, there's a problem where you can't really see the counties that are near Los Angeles because it's Los Angeles. So we can break the map apart from its exact state. Okay, we don't have to be in the shape of the United States to still represent the United States. So we can enable no county overlap and let these balloons blow up so that they don't overlap each other anymore. Now you can see all the individual counties. Nobody's hidden, but we're still visualizing population. And we are kind of halfway into the shape of the actual United States. It's barely recognizable. But still, you can kind of get a sense about where certain counties are located. So, and we can color by the margin now so that you can see the wishy-washy counties a little bit better, ones that are close to balanced. All right, so this is a little tour of different kinds of election maps. And what you can see is that by changing the nature of the map, we can enhance our understanding of different aspects of what is happening. If we want to see the popular vote, I think that we are looking at things like this, right? If you want to see an elector's vote, you would look at a different kind of map. So here is examples of many election maps. So these are not from 2020, these are from the previous election cycle. And you can see that each one of them has a very different form. So a Dorling diagram is showing you by size the number of electors, the number of the electoral college votes that that state gets. Okay? And it's once again, showing you roughly where that state is, but not exactly. You kind of have to squint to a line so that you can see by the volume of the symbol what is being represented. Here's an interesting one where the United States has been put through a kind of rubber sheet transformation where it's being stretched so that it's being stretched to make area proportional to population. So states like Wyoming have gotten shrunk down to nothing. There's not many people that live there. States like California are being blown up. So you can see just, when we look at all these different examples, how really there's not so much red states and blue states, right? What there is lots and lots of tiny little red things far out in the, kind of farmlands and wilderness areas. And then there's these splotches of blue. And you can see the population map very clearly where density of a population is correlated with, in this case, voting Democratic. All right, that was a fun little tour of election maps. I'm going to say Asta again for a little bit, and we'll come back again with a little bit of stuff about your choices when you're making visualizations.